Snellen chart. It is used to measure the vision of eyes individually, that is, separate for left and right eye. It is a chart consisting of alphabets which are placed in 8 rows in such an arrangement that the topmost letter is the largest, and as we moved on, their size keeps on decreasing. The size of the alphabets is specially designed so that a person with a normal vision can read the first row from a distance of 60 meter, second row from a distance of 36 meter, third row from a distance of 24 meter, fourth row from a distance of 18 meter, fifth row from 12 meter, sixth row from 9 meter, and seventh row from 6 meter clearly. To test the vision, the person is made to sit at a distance of 6 meter from the chart. The person tries to read from the chart with the eye which needs to be tested, and the other eye is covered by a cardboard or paper. If the person is able to read the seventh row clearly, that means that his vision is completely normal 6 by 6. But if he can't, we tell him to read the upper row, and if he can read that, that means that his vision is 6 by 9. Here, the 9 in the denominator shows that a person with a normal vision would have been able to read this line from a distance of 9 meter, but our subject is able to read it from a distance of 6 meter. Therefore, we have written 6 in the numerator. Let's assume that this person is not able to read this line also. Then we tell him to read the upper line, and we continue to do this till the person is able to read a line. Let's assume that the person is able to read the line at the third row. That will mean his vision is 6 by 24. Here also 24 means that a normal person could have read it from a distance of 24 meter, but our subject is able to read it only from a distance of 6 meter. So starting from the 7th row, we keep on moving up till the person is able to see clearly the alphabets. So it's like 6 by 6, 6 by 9, 6 by 12, 6 by 18, 6 by 24, 6 by 36, and 6 by 60. 6 by 60 means that the person is only able to read the first row alphabet. That means that a normal person could have read it from a distance of 60 meters, but he can read it from a distance of 6 meter only. What will happen if a person is not able to read even from a distance of 6 meter, the topmost letter? Then we will move the person closer to 5 meter. If he is able to read, then his vision will be 5 by 60. If not, then move more closer, 4 by 60, then 3 by 60, 2 by 60, and at last at a 1 meter distance. If he reads at a distance of 1 meter, his vision will be 1 by 60. That's the last reading we can take on Snellen's chart, that is 1 by 60. This means that a normal person could have seen this alphabet from a distance of 60 meter, but our patient can see it from a distance of 1 meter. So the best vision on Snellen's chart is 6 by 6, and the worst vision is 1 by 60. If a person is not able to see from a distance of 1 meter, then we do finger counting close to face. If he cannot count, then we test hand movement perception, and if this also not, then we see if he can perceive light. We put torch in front of his eye to see if he can detect the light, and if he cannot detect light, that means that the person is completely blind.